Hi there, Mr. Sutton bringing you the IM3 7-8 Extra Practice Number 1 solutions on degrees, radians, and reference angles. On this problem, I'm trying to convert this measurement in radians to something in degrees. So to do that, I multiply by 180 degrees over pi. My pi's conveniently cancel. And then 180 divided by 9, that's going to be 20. So I've got 34 times 20. So that's going to be, let's see here, 680 degrees. For this problem, I want to convert this angle into degrees because it's in radians right now. So I'm going to multiply by 180 over pi. Pi's are going to cancel, and the 180 and the 6 can also cancel, leaving me with 30 in the numerator. So we have 5 times 30, giving us 150 degrees. On this one, I'm trying to convert this into radians, so I'll multiply by pi over 180, and I have to reduce this now without a calculator. So definitely we can cross off those zeros. So we just really have 102 over 18. I can reduce that by 2 to be 51 over 9, and then I can reduce that by 3 to be 17 pi, because we have a pi up there, over 3. On this problem, I want to convert this into something with degrees, so let me multiply by 180 over pi. Pi's are going to cancel. 180 and 2 can cancel, leaving me with a 90 up there. So we have a negative 5 times 90. That's going to be negative 450 degrees. For this problem, I'm trying to convert this into degrees, so I'll multiply by 180 over pi. Pi's are going to cancel. And I know my factors of 180, so I happen to know that 180 divided by 36 is going to be just 5, which is really nice, because now I just have 11 times 5 in the numerator, which comes out to 55 degrees. For this one, I'm trying to convert pi over 12 radians into degrees, so I multiply by 180 over pi. Those pi's conveniently cancel, and then 180 divided by 12, well, I know my factors of 180. I know 12 times 15 is 180, so if I cancel those, that leaves me with a 15 up there. And we just had a 1 from there, so that's just overall going to be 15 degrees. For this one, trying to convert this into radians. So to do that, I multiply by pi over 180, and then I try to reduce. I'm not really sure exactly what I can reduce these by, but definitely 5 should work. So let's see here, 215 divided by 5, well, 200 divided by 5 is 40, so 215 divided by 5 is 43. And then we've got 180 divided by 5, I happen to know is going to be 36, because I've got my factors of 180 memorized. So we have 43, and there's going to be a pi on top, and that's all negative. So negative 43 pi then over 36, and believe it or not, we can't reduce that any further. For this one, trying to convert this into radians, so I multiply by pi over 180. And now if I reduce 225 and 180, I happen to know that these are both multiples of 45, which really saves me a lot of time. But if you didn't remember that, then you can certainly reduce by 5 and then also reduce by 9 afterwards. So reducing by 45, though, that's going to make this a negative 5 pi in the numerator, and then 180 reduced by 45 is going to give us a 4 in the denominator. For this one, trying to convert 360 degrees into radians, so I'm going to multiply by pi over 180. And this is a really nice one. I just have to reduce the 360 and the 180. I happen to know that that reduces to 2. Don't forget that we still have this pi up here, so that's going to be 2 pi. On this problem, I want to convert this angle into degrees. So for that, I will multiply by 180 over pi. Pi's are going to cancel. I can also reduce the 180 and the 6 to give me a 30 in the numerator. So negative 7 times 30 leaves me with negative 210 degrees. For this problem, I'm trying to convert 420 degrees to radians. So I have to multiply that by pi over 180 and then reduce. 420 and 18, I believe those are both reducible by 60, and I think that's as good as it gets. So 420 divided by 60 is going to give me a 7. So that's a 7 pi. Definitely can't reduce 7 anymore. And then 180 divided by 60, that's going to be a 3 down there. For this problem, I'm trying to convert 215 degrees into a reference angle. So I have to figure out the distance from this to the closest x-axis angle. This is closest to 180. So to get the distance there, I need to do 215 minus 180, which is going to give me 35 degrees. For this problem, I want the reference angle for 330, so I'm trying to find the distance between this and the closest x-axis angle, which is 360. To get that distance, a positive distance, I want to do 360 minus 330. So that's going to be 30 degrees. To find the reference angle for 19 pi over 9, let me first convert this to degrees. I'll need to do it anyway. So if I multiply this by 180 over pi, 180 divided by 9 is going to give me 20. And then 20 times 19, that's going to be 380 degrees. So to get the reference angle for 380, I want to first get that to be an angle between 0 and 360. So I'm going to subtract 360 to get me that coterminal angle. 380 minus 360 is going to give me 20. So now I need the distance between 20 and the closest x-axis angle, which happens to be 0. The distance between 20 and 0 is just 20, so this is actually our reference angle. To find the reference angle for negative 115 degrees, let me first add 360 so I can figure out where this is between 0 and 360 so I can visualize it better. So adding 360 to that, it's essentially 360 minus 115. That's going to be 245 degrees. And now I have to figure out the distance between 245 and the closest x-axis angle. Well, this is closest to the 180 side of the x-axis. To find the distance between this and 180, I will do 245 minus 180, because I want a positive distance. And then if I subtract those, that is 65 degrees for the reference angle. For this problem, to get the reference angle for 23 pi over 18, let's first convert this into degrees, because we have to, and also because it'll make it easier to figure out where we are on the unit circle. So if I multiply this by 180 over pi, 180 divided by 18 is actually going to give me 10, which is kind of nice. And then 10 times 23 gives me 230 degrees. So there's our degrees. Now I have to figure out how far this is from the closest x-axis angle, which happens to be the 180 side of the x-axis. The distance between 230 and 180, the positive distance, is going to be 230 minus 180, which is 50 degrees. To find the reference angle for 510 degrees, let's first figure out where we are if this were an angle between 0 and 360. So I'm going to subtract 360. We're allowed to do that without changing the position of the angle. 510 minus 360 gives us, that's going to be 150 degrees. So that's the angle that we're working with here. And now my task is to figure out how far 150 degrees is from the closest x-axis angle. This is closest to 180. So to find that distance, we're going to do 180 minus 150 so that I get a positive answer out of this, and that's going to give me 30 degrees. For this problem, I want the reference angle for 19 pi over 6. Let me first turn that into something with degrees so I can get a sense of where I am. If I multiply by 180 over pi, that's going to be 180 divided by 6, which is 30. And then I don't know what 30 times 19 is, but I know 30 times 20 is 600, so that we need 30 less than that, 570 degrees. So that's how you could get that without a calculator. And now I have to figure out the distance between 570 and the closest x-axis angle. So to figure this out, I'm actually going to subtract 360 from this so that I can get a sense of where I am if this were an angle between 0 and 360. I'll just be able to visualize what I'm doing better. So 570 minus 360, that's going to be 210 degrees. And how far is this from the closest x-axis angle? Well, the closest x-axis angle is 180 degrees. So to get the distance from this to 180, the positive distance, I will subtract 180 from 210, and that gives me 30 degrees. To get a reference angle in degrees for this one, let me first turn the original into degrees by multiplying by 180 over pi. So 180 divided by 6, that's going to be 30, and negative 7 times 30 is giving us negative 210 degrees. If I want a reference angle for that, well, let me figure out where this actually is between positive numbers here, 0 and 360. To get a positive angle out of this, let me just add 360 to it. That'll give me the position, but it'll just make it look a little bit different. So negative 210 plus 360, that's 150. And now I just need to figure out how far this is from the closest x-axis angle, which happens to be 180. So to get that distance, I just do 180 minus 150, and that gives me 30 degrees. On this problem, I want to get the reference angle for negative 350. To get started, let me add 360 to this so I can figure out where this is as an angle between 0 and 360. And then if I have to do a little bit more, I will. So negative 350 plus 360 is 10 degrees. And now we're just trying to figure out how far 10 degrees is from the closest x-axis angle. Well, the closest angle on the x-axis is 0 degrees. How far is 10 from 0? Well, it's 10 degrees. So 10 is its own reference angle, and we are done.